battery energy storage system solution in Korea. INCELL develops and produces lithium batteries based on its proprietary BMS and packaging technology to provide the most efficient energy and battery solution technology. They give their best to create various values and to have differentiated technology and excellent quality. They grow with their customers. Mr. Steve Jim, General Manager of Sales at INCELL, is with us. Mr. Steve, welcome. The floor is yours.
Oh, hello everyone. This is Steve again from INCELL in Korea. Nice to meet you, and thanks for joining these sessions. Shall we start it?
Yes.
Okay. From now on, I would like to start my presentations. And before we started these presentations contents, I would like to introduce our company. We are located in Korea. Our main business is ESS solution and lithium-ion battery packs. We started business from 2004. Our ESS reference is over 350 megawatt-hour. And we have a special bond with Samsung SDI and as a strategic partner and purchaser for the battery cell. And we also, good reference with Capco is a public corporations in Korea. One company supply the energy in the nations. And this part is battery solution. As you can see, battery application is very various. So as you can see from utility, commercial, ESS solution, residential, and telecom sectors, and UPS in data centers, and kind of industrial-oriented mobility solution, and other types kind of the tailor-made solution also available. Why I prepared from our company histories and these battery storage solutions, I would like to introduce to you our information is from our empirical data and from our third-party authors. And from now on, I would like to introduce from ESS application and battery energy storage system video for introduction and reference and fire safety. As you can see, I prepared the explanatory diagram. As you can see, ESS solution can be used in power plant and the kind of the renewable energy kind of, for example, the photovoltaic solution and the wind turbine solution, or with peak shaving or peak shiftings and backup solutions, especially in substation. A battery storage system normally used for the frequency regulations. In case of the substation, frequency regulation is important to increase the quality of the electricity. And right part is consumption part, as you can see, and kind of building or just a factory and residential area, they can use it with renewable energy solutions. As you can see, I clarified the storage technology by energy type. As you can see, there are 5 sectors. First of all is the mechanical type. It's kind of the hydropower, flywheel, and compressed air. And second one is we can call it battery solutions. Kind of secondary battery is you can use it certain times, kind of over 8,000 cycles or more. So this part is electrochemical part. So as you can see, really acid battery or nickel cadmium or nickel manganese, and also included in these sectors. A kind of flow battery also same. And third one is the electrical part, kind of capacitors or a superconducting magnetic energy storage also included. And fourth one is a hydrogen power. We can call the fuel cell solution. And last one, we use the thermal energy, like the sensible heat storage. And next one is I prepared the differentiations among the different battery technologies. As you can see, and there are 4 parameters. First one is energy density, and round trip efficiency, and third one is a lifespan. Fourth one is eco-friendliness. As you can see, energy density, round trip efficiency, lifespan, eco-friendliness. Yeah, lithium-ion battery is the #1 and first levels material or the solutions so far. And as you can see, others are not eco-friendly and not competitive. And this part, I prepared one of the explanatory diagram for applications. As you can see, depends on the discharge durations based on the per microsecond, second, or minute, or hour, or day, or week, or season. We have to choose different solutions. So very quick time, and we have to use supercapacitor. So supercapacitor cover from here to here, and flywheels here cover from here to here, and batteries cover from here minutes to the day, for example. And other solution also, yeah, should be used based on the requirement, for example. So based on the power requirement parameters, we have to choose different solution, I think that. And for your understanding, we prepared the video so we can watch it, and you can find out that shortly after watching these videos. Shall we start it? As you can see, container type battery energy storage system includes the battery system in there. In case of battery system, is battery tray and cell is assembled and packaged it. It is battery energy storage system. As you can see, battery pack is stacked up in the rack. So battery pack is many cells is a series of parallel connections. This video is a promotion video, but an audience can understand it. What is the battery energy storage system? How we make the system based on the battery packs and the battery management storage system. So as you can see, battery rack system level BMS connects to the power conversion system, and we can find out the energy from the BMS or EMS and so on. As you can see, is the on-grid solution depends on the solution. We can use the energy efficiently. So as you can see, this battery energy storage system linked to the substation, solar energy wind turbine solution. Okay, I prepared another illustrative diagram. As you can see, this one is a solar ESS solution. So the energy is generated from the solar PV, and the energy is moved via the PV inverters and go to the grid or load, or remains is go to the battery bank as a future storage energy, and then depends on the operation plan. customer or owner can discharge the energy from the energy storage system. So generate the energy from here and then go through via the inverter and then go to the grid on load. The load can be a kind of the in house and kind of TV, lightings, refrigerator, whatever. You can use it from the renewable energy or from the battery bank. And this part is our reference, but as you can, it is based on the real references. So it can be helpful to understand how we use the battery storage system. For example, first one is a UPS backup solution. So it is an emergency battery solution, can support the escalator or some things. And second one is our battery storage system also used for the agriculture area. So normally farm use the solar energy and then generate the energy from the solar, and they save the energy in the battery storage system, and then they discharge it for their purposes. And third one is microgrid solution we use to supply our energy storage system in the national park. And this also similar solution. They generate energy from the solar and via the solar inverter and power conversion system, and they get the energy and discharge it from solar and the battery storage system. And this battery storage system also used for the telecom sectors, especially the backup solution in the station, 5G station. And recently, I visited America for support the EV charging station linked with ESS solutions. So at various areas we use it to reduce the CO2. And this part is a utility solution. Someone called it is about the before meters. Initial phase, I explained it. And this solution supports the good quality of electricity from the substations to the load. So as you can see, we also participate in the big solution. It was about 24 megawatt backup solution. And last December, we also exported the overseas solution, but it is the same substation frequency regulation solutions. And as you can see, this part is about the renewable energy ESS solution in Korea. And as you can see, left part is solar panel was installed about the 2 megawatt power, and battery energy storage system installed 6 megawatt hours. And the right part is another side. At the time, solar panel was installed about the 3 megawatt, and the energy storage system installed about 12 megawatt hour. You may catch the difference. Maybe for example, in Korea, and 3 times or 4 times capacity of battery storage system installed, because we can get the energy from the solar about 3 hours or 4 hours. So it depends on this climate condition, we design it and then we can install it. And plus, in case of the Korea, our government give the subsidy programs to accelerate these industries about 5 years. So it was very attractive for the entrepreneurs, so that they generate energy about $1 and they can sell the $1 energy to the government pay back about the $5. And the contract is 20 years contract, kind of PPA. So it was very attractive and to accelerate this industry within the 4 and 5 years. Good. And oh, sorry. And this part is a compact size and the storage system. And this storage system is a compact size, so that's why you can use the unusable space kind of the under the panel. Normally, don't use it, but our solutions and in Korea normally use the compact size solution. So, for example, this site installed 100 kilowatt power of PV panel, and we installed 332 kilowatt hour battery energy storage system. It's very easy and quick and save the money, so we can make the tight budget. And we just started the foundation work and then just lay down on the foundation and just reconnect it, and we use the renewable energy plus and the storage system. And as you can see, this part is the peak shaping ESS solutions. So depending on the requirement, customer requirement, we normally install the inside kind of basement or the near to the building. But in case of the outdoor solution, we normally use the container or the temporary house. So this solution is make the money from the nighttime electricity fare for the daytime electricity fare. So for example, nighttime electricity is $1 and daytime electricity fare is $1.5 or $8. So difference between the daytime and the nighttime fare, entrepreneur or the business man make the profit. And nowadays, we also focusing on the EV charging stations. So as you can see, here is a PV panel in the parking lot, and this one is EV chargers. And this container is about 1 megawatt hours battery and storage system. And via the cabling works, we generate energy, and then remains energy go to the battery and storage system. And the cloudy weathers, the system use the energy from the battery energy storage system. So very eco-friendly solution. And this part, very important part. And from now on, I would like to explain the fire safety. As you can see, and this one is LFP and the storage system. Well, containers fired, and I just captured from the Twitters. As you can see, it was happened 2022, January 16th. Yeah, and this one is 2021, May 55th was happened in the shopping center in the Beijing. At the time, the capacity of battery storage system of LFP was 25 megawatt hours. Now, so you can make sure that nothing is safe. We have to use based on the right instructions. And right part is battery energy system fires in Korea. And last one is substation ESS fire in Arizona before. As you can see, everything is gone. We have to know that what happens. I think that the reason is the misused this battery energy storage system, or installation environment poor, or management is also poor. So those things are very important. And next part, how we prevent the below factors. So we also check the research data from the authorized third party, and according to their informations, and we can find out the 4 factors. Yeah, it's very critical things, very correct, I think that. Yeah, first one, insufficient battery protection system against electric shock. Yes, we think that the region of fire is kind of electric shock or short, kind of a short from external source or the internal source. So, for example, a lot of energy just quick, unexpectedly flow to the battery storage system and kind of inrush current and make the abnormal situation, and then the system can be a malfunction situation, and then we can see the unexpected situation, kind of fires. And second one, inadequate management of operating environment. For example, battery is kind of human heart. We just learned about the 400 meters, and then we can find out that our heartbeat is very fast, and then we have to take a rest, and then we can resume to run again. So depends on the speed or the operation condition, we can run continuously, for example. And third one is faulty installations. Yeah. For example, manufacturers supply the battery storage system with a user guide. But some engineer and some people do not read the manual, and they make the reverse engineering or something, and kind of reverse polarity, and then fuse is broken, everything is broken, and then they realize that I was wrong, for example. Or the installer just dropped the battery pack maybe as, and then some part is damaged, and once we learn the system, it can be a problem, for example. And fourth part is the ESS system integrations. As you can see the video, yeah, there are many equipment, kind of the PV inverter and bidirectional inverters or battery storage system, fire safety equipment, and battery energy storage system house. And everything is very critical things, so that we have to keep the temperature and keep the humidity and so on, and kind of the fire safety also importance. So some installers that do not understand the importance of a ESS system integration, and then they have problems. As you can see, lithium-ion battery system is PCS, lithium-ion battery system, EMS is energy management system. Three things are very important equipments and monitoring system. So as you can see, EMS software make an order, and PCS work, and via the PCS or the bidirectional inverter, try charge and discharge. And battery management system, kind of controlling software, sends a signal to the energy management service system, and EMS control and monitoring PCS condition and lithium-ion battery system condition as well. And as you can see, lithium-ion battery system need from cell and module with BMS and the rack system, so that we think that it's not difficult, because it's a cylinder type cell. We normally use this cell for the remote control, but it has a very high energy density, so we have to carefully use it. But if we use it under the user guide or standard, it is no problem, I think that. Yeah. So we find out how we deal with the fire safety. So we have in need of the unexpected vulnerable factors. So for example, we have to check the ours is a poor design or not. And we have to seek what is the inadequate part, or we also check the manufacturing defect or the faulty installation and overload operation. So this part, we can remove the stress point. So we use the ES dedicated cell. We use the environment monitoring continuously, and we have to suggest or use the our better energy system as a conservatively. And second part is about thermal runaway, kind of in large current and abnormal situation, and the battery can be a thermal runaway status. And at this moment, we have to use the off-gas kind of sensor. So this sensor can catch the abnormal situation. If we have a fire, we can use the hardware special plate. We can save the fire cascading. As you can see, normally in Korea use the inbuilt in BMS solutions to catch the abnormal situation immediately. And hardware part, we normally use the CLD rack cabinet, and we also prevent the flame come out. And we use the very conservative and very short range of the BMS. So as you can see, off gas is happen about the between 160 to the 200, and then we have to catch the abnormal situation. We have to freeze the situations. And as you can see, we also have a hardware solution with a special plate. We can prevent the fire cascading. And those things already explained in the report for the Arizona substation accident. According to their report, we have to handle the heat or temperature, and we have to use a small cell. It's because a big cell is kind of the dynamite, a small cell is kind of bullets. And cell quality important. We have to prevent static cell cascading and multi-module cascading. Ventilation, cooling is also important. And we can find out what is the difference and how we can prevent the fire, for example. I will move more. As you can see, 238, that's fine. We can find a smoke. After, about 4 or 5 minutes, we cannot see the products. So it is very important. At the initial point, we have to find out the abnormal situation. We have to stop fire cascading, and then we can protect our property, because it's a very expensive property, like a car, but you can use it with helping CO2 emissions. So we already got the UR 1973, and according to our test result, no fire cascading phenomenon from failed cell to the adjacent cells. That's all. From now on, I would like to get the question from audience.
Mr. Kim, thank you. Thank you for this great presentation. I have one question for you. How much of time is needed to charge batteries, depending on their sizes?
Depends on the operation plan, for example. For example, as I showed you before, someone installed a 1 megawatt PV panel. They want 3 hours charge and discharge. They need a 3 megawatt hours battery storage system. So we need to check the how much energy do you need it? From the renewable energy, yes, for example.
Thank you. Thank you for your time. Thank you for participation in our summit.